Hello everyone, welcome back to the Repair Bench, Classic Arcade Repairs. Sean here with you. Today I'm looking at a Cinematronics power supply, and it's got some really funky hackery to it. It's been worked on and the caps have been replaced with smaller caps, which I'm cool with, but we got to come up with a better way of mounting these things. Let me show you what's going on. Okay, yeah, you can see, oh, where's my glasses? Oops. Yeah, you can see here we got these caps. I've already clipped this. All of this electrical tape was wrapped all around these. This one went here. Excuse me. This one went here, and then here and here. So yeah, this is your positive voltage and your negative voltage. These are the 25 volt filters, 25 positive, 25 negative. And yeah, we're going to tidy this up and figure a better way of doing this. Okay, so let me kick around some ideas about how to better. These are going to have to go. These mounts have to go, and we're going to have to mount these caps, maybe do some terminal strips or something, and have a nicer, cleaner way. And this looks like this. Yeah, that's the screws holding the this guy on are loose-ish. Yeah, so we'll have to go through that. It's got one of those voltage controller chips on it. Yeah, we'll go over this board really good. We'll go over all of this, get a better solution for this, and yeah, go from there. Okay, I guess I'm just going to continue kind of taking this guy apart. Okay. This one is positive, this one is negative. Sniffles. And I'm going to have to undo all of this and remove all of this. Let's get these caps out of here. Okay. Yeah, these are, yeah, 22,000 at 50 volts. Those are good. That's fine. That's absolutely good. Absolutely good. Get this stuff out of here. All right. I'm going to have to see if I can't get these things loosened up. Come on. There we go. Let's remove all of these. I'm going to go ahead and cut away. This is going to take a while. I'm just going to remove all of this stuff, strip all of this out of here, and I'll come back when that's all done. Okay, I've removed these guys, these brackets. And in order to get this board off here, see it's soldered, this the TO3 package is soldered through the board there. This transformer is going to have to be removed. And I'm going to go ahead and just strip everything off here. I'm going to take the transformer off. I'll desolder these 2 points, these 2 points. I'll go ahead and just desolder this stuff, or I may just, I'll probably just desolder, remove all of this, remove this little board, and then we'll inspect and go over this little board. And this fuse is blown. The main fuse has been blown, so yeah. Yeah, so we're going to, and once I get this thing completely apart, I'll power this transformer and make sure that this transformer is good. It probably is. These things rarely go bad. So we will do that. Let me strip all of this off of here. I've taken good pictures. Take lots of pictures when you're doing something like this. The good thing is this black wire right here has no text. This one has white text. This one has white text, this bottom one has no text. So it'll be easy to know where everything goes, you know. Yeah, so, and here the coming off the capacitor goes into this side, and then this side of this fuse goes out. Yeah, so. I'll go ahead and continue stripping this all apart. Let's make it easy on ourselves. I don't want to have to be messing around with trying to remove this like that. I'm going to make it easy. Okay, I have this thing all off of the frame and just kind of poking around some diodes on here. I don't see nothing burned up. Everything looks pretty good. I am going to remove this chip right here and socket it just because. And while I'm in here, I might just replace these diodes. You know, put some new diodes in it. The cap has been replaced. All the caps are good. This guy's shorted. This little rectifier here is short. This little bridge. And I don't think I have this bridge. So we'll have to look into that. But I'm going to go ahead and pop this up here. Come on, get in there. Come on down. Can you see that? Okay. And let's probe. I'm in diode mode right now. And I'm going to go. And this wire right here, this blue wire, is not connected to anything. Neither is the yellow. This is the negative output. This is the positive output. And the two brown wires are AC. And if I go from the brown wire to this blue wire, you can see it's short. And it's good to this wire, the yellow wire. But yeah, it's shorted this way. So, and here we have nothing, and short. Yeah, so it's shorted on that negative 25 volt line. So I'll have to replace this diode, this bridge. Looks like it's a 3 amp bridge. No, that's probably an 8 amp bridge rectifier. I'll see what I got to replace that. I may have something. Alright, I was getting some goofy readings when I was trying to read these 3 amp diodes on this board. They go right here. And I want to look at the schematic and see exactly what circuit those are in. They're rectifying. Those might be, I don't know what they are. We'll find out. Those might be the diodes that are setting the ground level for this board. And I was getting weird, like charging capacitors. It just looked like capacitors were charging when I tried to read across these diodes. Like I wasn't getting a voltage drop. And let me try to put this here so that you can see this meter. Okay, let me do this. All right, move that a little bit. You can kind of see there. I'm going to try to read these diodes. These are both open. Okay, this one right here, open. Both of them. This thing would have no ground level at all. I believe we're going to go in and look at the schematic. I believe these two diodes are what are rectifying the negative half of this of AC to set the ground, to set the reference level on this board, as I believe what's going on. And this one is also open. Yeah. Now these two, I just dropped one of them. These two little guys here and here, these ones are fine. You can see there's this one and this one. You get nothing that way, but this way you get a reading. Good. And this one should be nothing this way. Good. Yeah, this one should be nothing this way, but should get a drop this way. Nothing. This one should be nothing this way and should get a drop this way. Nothing. Both of those 3 amp diodes are open. Interesting. So we had a shorted diode rectifying. See, this is a different transformer. This is a little different than the. Oh, this is not. I didn't do a Cinematronics before. I did a. What was that? Sega Gremlin. Yeah, the Sega Gremlin one was similar. No, not the Sega Gremlin one. I'm getting all mixed up. The one with the little gremlins running around, Death Race. The Death Race power supply was a lot like this, but it was different. The transformer on that one, the 20 volt peak to peak AC was shared between making the ground reference and making the 5 volt circuit. This one's different. It's separate. But I believe that is what's going on. I think, like I said, we're going to have to look. But I think what that's doing is setting that ground reference. So let's go take a look at that. These things are all getting replaced. Yeah, but I was just getting weird readings that I wasn't getting a short when I was reading across them on here. I was getting to where it looked like a capacitor was charging. I wasn't getting a diode drop, so I knew something wasn't right. So I was like, well, I better remove these things and check them out of circuit. And sure enough, the 2 big ones are garbage. And I did remove this chip as well, and we'll socket that, and so that it's easy to replace. I may even remotely mount a Darlington on this thing, just so that it's easier to work on in the future, you know. But I'll test this one, and I'm going to go ahead and throw these diodes in the pile. And I'm going to take that Darlington off of that frame, test it out, see if it was good. It's getting replaced regardless, but I just want to know what was wrong with this thing. So far, we've got 2 bad diodes and a bad bridge. So this thing had some serious issues. Yeah, just from looking at this, I got this thing repopulated with the new diodes and the socket. But just by looking at these, both of the anodes come together, you see. And these two black wires right here are where the AC comes in to here. The AC comes in here, the AC comes in here. And the negative side of that sine wave is being rectified and dumped onto this big track right here, this big trace. And that's your negative, that's your ground reference. It's just it's setting the ground reference for this. So that is that. So we got our new diodes in, we got a socket. I'm going to clean this board up, spray it down and scrub it clean. And that'll be good to go. I tested this guy. It's technically it tests good, but it just had some kind of weird wacky readings. Like one of the diode drops was 0.800. Yeah, so I don't like that. But I am going to replace this guy with this is a 6055. I'm going to put a 6059 in it. It's a little bit better of a transistor. It's just a little higher rated voltage and current capabilities, so we'll do that. I'll put a new voltage controller in it. I got to get a new bridge, and yeah, that'll do. So let me go ahead and clean this thing up. We can consider putting this stuff back together. Okay, before I call it a night here, and I had to order that bridge rectifier, this guy. I had to order one of these. I actually bought 5 from Mouser Electronics. Exact replacement. Actually, the one I'm putting in is an 8 amp, which is what this is. This is a 400 volt. The ones I bought are 1000 volt. Why not, you know? But what I am going to do, and I just got to thinking about this. These are 3 amp diodes, right? And we've already established that these diodes right here are what set that ground reference for this circuit, this 5 volt circuit. Now, if this 5 volt circuit is pulling 3 amps, if the board, and it's all TTL, it's, you know, Cinematronics stuff is all TTL. So if this thing is pulling 3 amps, that's going to be an awful hard load on these diodes, because these are 3 amp diodes, right? So current is going to be flowing at the rate of the 5 volt circuit through these diodes. I don't like that. That's might be why these opened up in the first place. These are kind of inadequate. You know, these were 3 amp diodes to begin with. So what I'm going to do is I'm going to put 6 amp diodes. I'm going to remove these, and I'm going to put 6 amp diodes in their place. That way, it'll just be more sound, because that's awfully close. I mean, this is going to be, I would say that board will pull close to 3 amps, if not 3 amps. And yeah, those are 3 amp diodes. I mean, that's the reference. That's setting the reference. That's probably why they are both open, just worked too hard. You know, they're right at their limit. So yeah, we're going to put some 6 amp diodes in there and make this thing a lot more reliable. All right, power supply. I have 6 amp diodes here now. 6 amperes, so that is much better for that. And on this, instead of, now I did buy some 8 amp, you know, bridges for this, and that's what is in here to begin with. But the way I look at these bridge rectifiers, if it's an 8 amp bridge, I look at it as 4 2 amp diodes. Just the total amperage divided by 4. So if this is the equivalent of 4 2-amp diodes and you have a 3-amp circuit breaker, it's completely inefficient. I believe you should have the capability of supplying enough current, at least for what it's fused for, right? You want it to be able to successfully and nicely and comfortably provide at least up to 3 amps of current, right? At 3 amps, this is going to pop. If it gets much over 3 amps, these will pop. So why would you have a 2-amp diode in here? It makes no sense to me. So I mean, this thing was just designed poorly, with these being 3-amp diodes here in a 3-amp power supply running at their absolute maximum, and this thing running beyond its maximum. No wonder you have you have shorted and you have open diodes on this thing everywhere. So yeah, it just needs to be upgraded a little bit. So I've got a standard, a 35 amp bridge on here, and that is, that's close to 9 amps per diode. So that'll provide plenty of current. It won't be stressed, and it's not going to short out or die like this little guy here. So just an upgrade. So I'm ready to put this thing back together now. I've got my 6 amperes in here. Like I said, I got this guy ready to go, and I am going to put in a new Darlington. I'm using a 6059. I believe I said that. I don't have that other kind. I don't have any more of the nice TO247 package one. So I'm going to use a standard one. Use it how it's designed. Put this thing together, and yeah, it should be good to go. So I'm going to get to it. Okay, we're done. Let's talk about what I did here. Okay, I had to get the old drill press out and drill a couple holes to mount these caps like this. I have a 35 amp diode here. That's overkill for that circuit, but it's better than the 8 amp rectifier that was in there. If you remember, we replaced those with 6 amp diodes for that circuit. Okay, what I did was, how all those screw terminal things were all screwed together or whatever. What I did was I cut the terminals off and I soldered all those wires together, twisted them all together and soldered them together, and then I took one wire from that, or one wire, and soldered it onto the cluster of 3 wires here to have one wire coming out. So in a sense I had, if I draw it, and here's the little schematic that I drew for this thing of what I was doing, so I didn't get caught up on what I was doing. Those are your colors there. You have this is the bridge, and the positive, the yellow wire off that comes over to here, the positive side of the cap, and then over to the circuit breaker, and then the negative goes to the blue wire goes to the negative side of the cap and then to the circuit breaker, and then you have all these grounds tied together and one ground between them. So yeah, we have this ready to go. But if I draw out what I did, say I got those 3 wires, I twisted those together, and then I put another wire in there and twisted it, and I soldered that connection right there. So you have 3 wires down to 1, basically, is what I did, and then I ran that to the cap on the ground side. The ground side of this cap and the positive side of this cap. So instead of having 5 ground wires, I just had 1 ground wire. And then I would have 2 wires coming off of the filter side of the cap going to the circuit breaker or to this, the rectifier. So there's, that's how that's done. And it's zip tied really good with good high quality zip strips here. Heat shrink over all the solder connections, nice and neat. I had to extend this black wire, so I soldered another black wire onto it and heat shrank it. Yeah, we got our new 6059 Darlington amp transistor. These are on here good. I got new fuses in it. So we will go ahead and hook it up, fire it up, and give it a test. Put it under load. All right, we're ready to do some testing, I suppose. I got a printout of the pinout of the input and output connector, and I've got my line in wired up, and just a minute, I'm going to turn the furnace off. I'll be right back. Okay, yeah, I turned it down. It should be turning off here in a second. I got the meter set to AC. And just really something quick. Number one, this does not have a 5-volt adjust on it that I just now realized this does not have 5-volt adjust. That's kind of cheesy. This is kind of a cheesy power supply, to be honest. And it was manufactured cheesily. Very cheesy. I got to thinking about this power supply. This thing was not made to last. You got two 3-amp circuit breakers. This is a 3-amp power supply, right? You've got 3-amp diodes setting the reference voltage for this 5-volt circuit. And you've got what amounts to 2-amp times 4 diodes on the 25-volt and negative 25-volt circuit. I mean, that is just absolutely inadequate. You know, now we're looking, now we have 6-amp diodes here, and we have a 35-amp rectifier here. So that really ups the quality of this thing big time. But we're ready to fire this up now and go just preliminarily check unloaded, check our 30 volts, 25, whatever, 25, negative 25, and 5. So we'll go ahead, probe those. I'm on AC first. I want to check the AC in this bridge rectifier and that kind of stuff. So it looks like this tab right here is ground. So I can use this tab to check my AC, DC voltages. All right, cool. Yeah, let's fire it up. And it is on. And I want to check the AC at this rectifier, this bridge. And we have almost 50 volts. Good. 25 volt from the center tap out, so 50 volts peak to peak. Okay, good. So let's switch this to DC volts. I'm going to put the ground on this ground tab here, and we'll check our negative. Yeah, there's our negative. It's negative 32, negative 33 volts. Here's positive. We got positive 32. Good. And 5 volts is right here. There it is. There's our unloaded 5 volts. So we are good on our power unloaded. Now we got to load this thing down. I'm going to turn it off, and I'm going to get my resistors for loading this thing, and I'll put about 2.5 amps across 5 volts, and maybe like half an amp or something like that across the 25 and then negative 25. So let me get that all set up. I'll be back. Okay, I now have, this is 2 ohms. It's 2, 4, 4 ohm 25 watt resistors in parallel with each other. So it divides it to 2 ohms across 5 volts is 2.5 amps. So we're putting 2.5 amp draw on this 3 amp supply. And in theory, this is all that should ever be across this at the most. So let's go ahead and turn it on. I've got my red lead on a 5 volt hook. So all I got to do is take my ground here and put it to here, and we should get 5 volts. So let's go ahead and fire this thing up. Okay, it is on. And let me go ahead and touch this to this ground. And there you go. So we have 4.95 with a 2.5 amp load across it. Yeah. All right, so now all I have to do is calculate 30 volts. And what kind of resistance do we want across 30 volts to get about a half an amp to an amp, maybe 3/4 of an amp. Yeah, she's warming up. We got our current going through there. You can feel it. Nice and toasty. Not hot, but it's getting there. It's warming up, getting toasty. Yeah. Sweet. All right, that's good. I'm going to turn it off. That's a successful test. Okay. And I'm going to leave that there so that when we're always going to be putting that 2.5 amp load across it. And I want to put a load across the 25 and the negative 25. Okay, so yeah, plus a negative. There's your ground for that. So that's what we'll use for ground. And there's our two 25 volt pins. So let me go ahead and get a load for that, and I'll be back. All right, this is what I came up with to test the 33. It's 33 volts, 33 and negative 33. And I got Ohm's law wrote out here because I want to figure out what the wattage is and what the current is. This is 51 ohms. It's just some resistors in series, and I got two 25 watt, and then I have a couple 22 ohm 10 watt. So that's 22, 44, 45, 46, 47, 48. It's 48. It came up to actually 51 ohms. You know, the exact measurement on my fluke was 51 ohms. And then we had 33 volts. So our current, well, current is voltage times resistance, or over resistance, voltage over resistance. And that gave me 650 milliamps. Right at. Okay, then you got to figure out your power dissipation, your wattage, and that is current times the voltage. Well, you take that 650 milliamps, multiply it by 33 volts, and you get 22 watts. So we need to dissipate 22 watts of power. This is going to get toasty. These 10 amperes are going to get a little toasty. But we're not going to have it on there forever, you know. So it'll be good to test this. We're going to be running 650 milliamps through the 33 and negative 33 circuits, one at a time. I'm going to do the positive first, and then we'll do the negative, and make sure it's all working. And all the while, we'll have our 2.5 amps on the 5 volt. So, all right, let's do it. Okay, I'm hooked up to the positive 32. I have it all hooked up over here according to the pinout. So I'm going to go ahead and fire it up. And we're running. And I'm going to hit this ground and measure that. Put it into volts. Okay, we got 31 volts. Okay. Yeah, and you can feel it. It's getting toasty. That was just the power cord adjusting itself. Yeah, these 10 waters are really warming up. Yeah. And our negative is probably still right at 33-ish. Yeah. Okay. Positive's good. Now I'm going to turn it off. And before I do turn it off, let's check our 5 volts for the heck of it. And 5 volts is still right where it should be. I'm going to turn it off. Yeah, those 10, ooh, those get hot. Those, ooh, yeah, those 10 waters are really hot. So let's move it to negative. Now we've got it on, I've just changed the pin to the negative 25 pin. And go ahead and turn it on. Now we're on the negative. So let's check the voltage on that. It should drop a little bit. And it dropped down to 31.2, and this should be back up towards 33 because we're off of it. Yeah. There we go. There's your negative with a load. More load than it'll probably see. And here's your -5, or your 5 volt. That's your 3 voltages out of this guy, and this thing is hot. Yeah, those 10, I'm going to turn it off. That's good enough of a test, to be honest. It's still on. But yeah, works good. And those are new caps. So, and that little board has new caps. So that's it. We're tested. We're good. This is hot. Fire hot. Go ahead and turn it off. And that's going to do it for this one. Hope you guys enjoyed. And thanks again to all the Patreon supporters. Appreciate every one of you, as always. And yeah, kind of a nice little quick power supply repair. This thing looks pretty darn cool. Looks a lot better than it did when I got it, doesn't it? Nicely mounted these. Got a nice new rectifier here. A little bit of upgrading parts. Yeah. That's where everything's plugged in. All right. Thanks, guys. We'll see you all on the next one. Bye for now.